Okay, so the stuff we were talking about on Friday, mean value theorem for integrals. Okay, what are the criteria that we have to meet for the mean value theorem to apply for integrals?
Continuous.
That's it. There's only one criterion. That's it. They just have to be. Okay, so we can check that off. Where? Oh, there they are.
I got 4 because one of them might not be good for it. See, I told you the rain is spotty, you guys. Yeah, no, I don't want to know.
Okay, can we check that box? Yes, we can, right? Yeah. We met the criteria.
I think that he does seem like that. Yeah, that's what I think. Like when you I was like, oh my gosh. I just saw him in the hall too.
Okay, so we meet the criteria, right? Everybody with me here real quick. So we meet the criterion. Then what is the mean value theorem for integrals?
Isn't it A minus A?
It's b minus a. Yep. There you go. So, oops. Okay, so here is the mean value theorem for integrals. Right? Mean value theorem for integrals tells us that if the function is continuous on some interval, then its average value is going to equal the area under the curve divided by the width of the interval, right? So for us, let's see, for us, f of x is 2 secant squared x, right? So what's this all going to become? This is going to become integral of 2 secant squared x dx from negative pi fourths to pi fourths divided by, what's the width of the interval? There you go. Pi over 4 minus negative pi over 4, which is just pi halves, right? Okay, and what is the antiderivative of secant squared? Tangent, yeah. Okay, so then we could take the 2 out in front. That's a constant. So we get 2 times tangent x evaluated from negative pi fourths to pi fourths all over pi halves, right? Okay, so think unit circle. On the unit circle, pi fourths is right there, right? What are the coordinates of x and y at pi fourths on the unit circle? Square root of 2 over 2, square root of 2 over 2. So what's the tangent then? Because the x coordinate is the cosine value, right? Y coordinate is the sine value. So tangent is sine over cosine. So it's 1, isn't it? Right? We get square root of 2 over 2 divided by square root of 2 over 2. So we get 1. Good. What is the tangent of negative pi fourths then? Negative 1, exactly, right? Because here the x coordinate is root 2 over 2. The y coordinate is just negative root 2 over 2. So we're going to get negative square root of 2 over 2 divided by positive square root of 2 over 2. So negative 1, yeah. Right? So we get 2 times 1 minus negative 1 divided by 2 pi is the same thing as times 2 over pi. So I get 2 times 2 times 2 is 8 over pi, right? That's my average value. Okay. So then, now here's the part that's kind of weird. So use technology to find where the function has its average value, right? Because the mean value theorem for integrals says that there's going to be at least one interior point where the function passes through its average value, right? So then we're solving for c. We want to know when is f of c equal to 8 over pi. Well, f of c is just 2 secant squared c. How would I solve that equation? Divide by 2. So secant squared c, or call it x if you want to, equals 4 over pi. Now what? Square root, because I want to isolate the secant, right? So if I square root both sides, I'm going to get secant c equals square root of this is going to give me 2 over the square root of pi, right? And now what? Okay, good. So we could flip this. Remember, secant is the reciprocal of cosine. Cosine and secant are reciprocals of each other. So I could flip both sides and get cosine of c equals the square root of pi over 2. Well, that's obviously not a place on the unit circle that we know. So this is where you would have to use technology. You don't have a choice, right? I mean, you could write an answer, but it's just going to be an arc cosine. Okay, this is the thing we want to talk about, though. So if we're looking between negative pi fourths and positive pi fourths, think about the unit circle here. Square root of pi over 2 is going to be what kind of number? Square root of pi over 2, it's going to be positive, right? And square root of pi over 2 is going to be some number that's less than 1. Agreed? So if we want to know where is cosine equal to square root of pi over 2, where is cosine positive? Cosine is the x coordinate. Yeah, so if we pick some angle, like let's just arbitrarily, we're just going to say that this is the angle theta that's going to give us back the x coordinate square root of pi over 2, right? Everybody agree? The cosine of that value, actually, it's c. It's not theta. It's c. I already had a name for it. Okay. Well, where else, if we're looking between negative pi fourths and positive pi fourths, if that's our domain, where else would the cosine have that positive value? Yeah, it's going to be, everybody agree, in quadrant 1, but also in if I look down here in quadrant 4, that point right there is going to have the same x coordinate, isn't it? Okay, well, how could you describe that place? One way you could describe it is 2 pi minus c, but our domain is going from negative pi fourths to positive pi fourths. So where in our domain would that be? If this angle is c, what's that angle? Negative c, isn't it? Everybody agree? So what would my two solutions be? Well, I'm going to get two answers. I'm either going to get c equals arc cosine of square root of pi over 2, or c equals negative whatever that angle is, arc cosine of square root of pi over 2, right? Now, if we're just trying to find decimal answers, right, which presumably we're doing here, it's asking us to use technology to find the average value. Okay, so then we could just graph this thing, couldn't we? In Desmos. We could just graph our function f of x equals 2 secant squared x, we're only looking between negative pi fourths. So we'll go negative pi fourths to positive pi fourths. And we'll go by steps of pi fourths, how about? Okay, and what are we trying to look for? We want to know where is f of x equal to, secant squared was equal to 4 over pi, right? So we could just say y equals 4 divided by pi. Oh, what happened here? Secant squared c. Oh, no, not 2 secant squared, just secant squared. That's the problem. There we go. Let's see, that didn't work. Okay, and then all we have to do is just find the intersections, right? We want to find out where does our function equal, where does it pass through the line y equals pi fourths, and those will be the solutions. For our beautiful notes, I'm going to just stretch out the y-axis a little bit. So we could just go from negative 1 to 2. Yeah, that'll work. How about negative 1 to 3? Okay, everybody good with that?
Yeah.
If we want to find the places, then we'll just go either there or there. So the values are either positive 4.817 or negative 4.817. I bet you money that is probably about 4.817 is probably about the arc cosine of pi over 2, square root of pi over 2.
It was. Yeah, it was.
Mm-hmm. Yeah. Okay. Okay, everybody good with that? All right, I am going to give you guys a day to catch your breath on this stuff before we jump into new stuff tomorrow. So try to get caught up. I know we've had a lot of stuff thrown at you, but try to get caught up because we're moving into kind of a new. Well, mean means average, doesn't it? Right. So you got an average value theorem, mean value theorem.
That's just the
Integral. Area under the curve is the definite integral, right?
And then you do your top minus the bottom.
Yep.
I don't know how to get into this.
Yeah. Well, you see, to practice. It's at this point, it's all about practice. Calculus, more than anything you've ever done before, just takes practice. There's just a lot more stuff to do, and so you got to.
I was looking at the math class I had to take at BYU next year, and it's calculus 1, and it was like, we're going to talk about limits and integrals and derivatives, and I was like, boom, 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 easy.
That's right.
Easy money.
That's right.
Although I don't understand what any of that is. So. Never mind.
Yes, you do.
Like when you're like,